Hello everyone, this is the smart home control application that we have built for the assignment. There are three applications in it. The simulator application which simulates the house, and the mobile application that user can add floors, houses and the components to the house. It will simulate seamlessly inside the simulator web application. And backend, there is a backend also. If we dive into the technologies that we are used, we use React for the front end development, and for the back end we use Node.js, and for the databases, we use non-SQL database for seamless updating, because they are because we want faster connection between the database calls. So for the object storage we use Firebase object storage, and for the hosting purposes we used Railway for the backend hosting, and Firebase for the front-end hosting. And let's dive into the features of the application. My colleagues will explain about the other parts of the application.
This is our mobile application. We can simply add a house. I use sample. Okay, now we create a house. We can have separate houses. In the house we can upload an image. For then we can simply recognize the separate houses. We'll build this app using the React Native. Okay, the house is there, so we have 4 houses. After we add in a house, we can add a separate floor. There can be multiple floors. The first one is ground floor. We can simply create the ground floor, and there is a grid, actually width and height there. After we create in our ground floor, we can go to the ground floor and add an image for that. So there is a more clear way to see the ground floor, and we can get a better understanding in the ground floor. Okay, we select this one. Okay, that's good. Ground floor is there. At the ground floor we can add many devices, and we can mark it as any place of the grid. According to the x and y coordinations, we can move our devices in anywhere of that grid. Okay, now we have to add the proper coordination, so we can move you can simply see that the outlet is going here and there according to our x and y coordinations. If it is a light or camera or any other device, we can select the type of the device and we can place it according to our grid. Okay, there is a schedule enabled. This schedule means there is a start time and end time. The device automatically follow that start time and off time. When that is off, it's gonna off. Okay, in here we can see the multiple device types. If we need lights, we can only filter that out and see the lights. Okay, this is the scheduling part. If the light is on, we can on the light. If we need to turn off, we can turn off, or or if we need to delete that, we can simply delete using this one. We can add several devices in a flow, it doesn't matter count. Okay, the bulb follow the scheduling part, so we simply off the schedule and we can turn it on by manual. Okay, when we go to the ground floor, okay, you can see that the bulb is turned on. We can add another device. We go to the camera. There's a multiple options in camera, so in the demonstration purpose I will add a camera for the full area. Okay, we need to turn it on. Okay, now we see there is a camera. Okay, the camera is there, and we can turn on the bulb also. Okay, the both items are working separately. In here we can add the area, actually angle, the degrees where the camera is pointing. That's much more helpful to understand where is the pointing area of the camera. So we simply save it, and when we go through the flow, we can simply understand what area is gonna camera is cover. Okay, this is alert part. In here we can see if there is any hardware fault happens, these alerts come to our notification section as well. Okay, there is a alerts section. This is a report section, how our usage is going on. This is White House, our previously created house. How it works at 7 days. This is just now we created a sample house. No, then it's 1 minute. Okay, now we get to know what's this technical faults. When we go to the house, it actually was the White House. Okay, in there actually the ground floor. Okay, this is the completed housing sections. You can clearly understand there is a fault in a one plug points. When we go there, we can simply see that there is an error. So in the edit sections, we can edit when the error is done. With that, we come to the end of our presentation.
To bypass physical component constraint while maintaining a realistic IoT deployment experience, we develop a web-based hardware simulator dashboard. This simulator represents the physical home appliances listening directly to database updates and visually reflecting changes online. I am going to start by showing the simulation web app, then dive into live home simulation where we can inject a real world smart house and watch everything update in real time. Here we are at the landing page. We can see every house in the system. These are cards with the name and the image of the house. The top right sync badge tells us we have a live connection to the Firebase real-time database. Each card is clickable. Every end points to simulate house. Let's select this house to see its simulation dashboard. Here we can see floors of house, uh, ground floor, first floor, second floor, and this is the plan image of the ground floor. Each floor has a plan image view right here, overlaid with the blue grid. The plan image shows the actual layout of the house. On top of it, we position each device using grid X and grid Y coordinates, uh, exactly as replaced by the mobile app. You will notice icon for outlets, lights, cameras, multi-switch units. This represents the physical appliances in the room. Let's walk through each type. Outlets. First, they can be replaced by the mobile app and then activate remotely. When I toggle an outlet on in the mobile app, we can see status update here. The outlet node on the floor plan pulse softly when on, and the status scripts reflects the change. This is the same live sync at powers the entire system. Lights. In here we have lights represented by the bulb icon. Like outlets, they can be controlled from the mobile app, but they also support scheduling. In the inspector, we see a schedule plan where you can set scheduler start at scheduler end time. The light will be automatically turn on according to the schedule, and the dashboard shows the current status live. Cameras. Here we can see mockup camera snapshot URI stream. Here the inspector shows the live feed. New snapshot are pushed every 6 seconds automatically, or we can manually push mockup through using the simulator panel. Each snapshot fades it smoothly, and then multiple switch units. Finally, multi-switch units. These are boards with multiple independent switches. The floor plan shows one glip, but when we open the inspector, we will see individual toggle rows for each bulb switch. Each subswitch has its own label and status. Now the real power of this dashboard, we can inject realistic failure scenarios without touching any physical hardware. Here at the bottom of the dashboard we have error injector panel. It acts on the currently selected device. Trigger error. Set the device to error and node turns into red. Uh, and a warning alert appears in the alert log. Disconnect. Simulate a network loss. The node was dashed and dimmed. Save in here. We can clear faults. Most importantly, because all clients share the same Firebase real-time database node, any changes we make here appears in the mobile app within a second, and vice versa. If I toggle a light on the mobile device, the web dashboard updates instantly. If I inject a error here, the mobile app shows the same red status and alerts. This is the core of our architecture: one database, many clients, all reflecting the current status of the simulated home.